Hi, welcome to this instructional video by See Your Future. I will be discussing the question, what is Kevlar and how is it made? The most simple and direct answer to this question is that Kevlar is a molecule. Molecules are microscopic structures that compose almost everything around us in our universe. More specifically, molecules are two or more atoms bonded together. One of the simplest molecules is sodium chloride, represented by the formula NaCl. Sodium chloride can also be represented by a Lewis dot structure. Once again, we write the letters Na for sodium and Cl for chlorine. The line between them represents a chemical bond, which is formed by the sharing of two electrons. The dots around the letters also represent electrons, and they show that each of these atoms has an additional 6 electrons in its outermost shell. Sodium chloride also goes by another name. It is often called table salt. This is the same salt that you may find on some of your favorite food items, such as this nice plate of French fries shown here. Now we return to our original question. What is Kevlar? Well, Kevlar is a molecule, just like sodium chloride, but its structure is much more complex. Once again, I will draw a Lewis structure to represent one molecule of Kevlar. As before, letters show the positions of atoms, and lines show chemical bonds between these atoms. The two hexagons that you see in this drawing are a shorthand way for denoting a ring of carbon atoms, that is, 6 carbon atoms arranged in a hexagonal ring structure. Shown here is a single molecule of Kevlar. However, when Kevlar is created, many molecules of Kevlar bond to each other to form long chains. This is represented by the brackets and the N in the lower right-hand corner. This shows that Kevlar is able to form what is known as a polymer. The ability of Kevlar to form a polymer, however, is not the only reason why it is so strong and durable. The secret behind Kevlar's strength comes from a more advanced topic in chemistry, dealing with intermolecular forces. I will not give a full explanation of these forces for this video. However, if you are more familiar with chemistry, you will know that Kevlar derives its strength from hydrogen bonding and pi stacking interactions. These interactions occur between adjacent polymer chains. Now that we know the general structure of Kevlar, we are ready to talk about how it is synthesized. Once again, a detailed description of how Kevlar is synthesized is a bit beyond the scope of this video. However, I will list the chemicals that go into creating Kevlar. The first of these is called paraphenylenediamine, and the second is called terephthalochloride. If you look at the structures of these two molecules, it is relatively easy to see how they fit together to form the Kevlar molecule. These two molecules can be mixed together in solution to form Kevlar fibers. These fibers, which are made up of many of the polymer chains that we discussed previously, can then be removed from the solution. Lastly, these fibers can be woven together to be put to practical use. This leads me to my last topic that I will discuss, which is the applications of Kevlar. Kevlar has many uses. This is because it is both strong and lightweight. When Kevlar was first created, its intended use was for the strengthening of car tires. But researchers quickly realized the versatility of Kevlar. Soon thereafter, the use of Kevlar to create bulletproof vests and other types of body armor made it incredibly famous throughout the world. Kevlar can also be used for mooring lines, which allow ships to be attached to a dock and keep them from floating away. For any musicians listening, you may be interested to note that many drum heads now contain Kevlar to increase their strength and durability. These are just a few examples of how Kevlar is used. However, there are countless others. Kevlar is a truly versatile molecule that will continue to be used in many aspects of all of our lives for the foreseeable future. I hope you enjoyed this video and that you found it to be helpful. If you have any questions about what was shown in the video, please type them in the comment box below. If you have a question on another topic, please send us an email at questions@syfuture.org. Also, take a look at our YouTube channel for a full list of instructional videos. You can access this channel through our website, www.syfuture.org. Thanks for watching.